Okay, let's talk business. Let's just go right into this, guys. There are three scenarios, and let's go over the three scenarios that you're going to get. Scenario one, all the area is above the x-axis. So sketch quadrant one, I'm going to exaggerate it. I'm going to say that's A, I'm going to say that's B, and I'm going to say here's a curve. I'm going to call that curve f of x. And I am going to draw vertical lines, A and B. And I'm going to say that that is shaded. And that region that is shaded has an area of 10. So how do I say that? I say area from A to B of this function is 10. The A is the start. The B is the stop. Nothing crazy, pretty straightforward. All right, scenario two. Some area above the x-axis, some below. All right, so I'm going to exaggerate quadrant one and quadrant four. And I'm going to draw a little bit below and a little bit above. And I'm going to call this point A. And I'm going to call this point B so I can draw a vertical line, because I wanted a vertical line. And this is just shaded, and this is shaded. Obviously, the area above the x-axis is bigger. I like the number 10, so I'm just going to keep writing 10 until I don't see the 10 anymore. And I don't know, this looks little. What looks like an appropriate number for that? 3 or 2 or 4? Not 3. Sorry. So what I'm trying to tell you is that the area between A and, I don't know, this little blue spigot, can I call it that, spigot? I don't know what a stick, a line. The area between A and that little dash blue line is 3, because area can't be negative. But when I write the integral symbol, when I write area from A to B of this function, and I got to call it something, so there's f of x dx, we're not going to say that that area is 13, because we have some that is below the x-axis and some that is above. So we're going to say that is 7. If it's below the x-axis, it's negative. If it's above the x-axis, it's positive. Negative 3 plus 10 is 7. So I guess let me write that for good notes. Negative 3 plus 10. I like the number 7. I don't know why. I like the number 8 too. I'm actually a little jealous for those people that were born August 8th in 1988. Why couldn't my parents have me that day in that year? Okay, anyways. No, I mean, 8888. No, 9999. I do. I like all the numbers. There's no number that's better than another. I mean, maybe pi, right? Or E. All right, last scenario. All below the x-axis. So exaggerate quadrant 4. And I'm just going to draw a curve. Here's a curve. And that's f of x. And I'm going to say this is A. So I'm going to draw a vertical line. I'm going to say this is B. Another vertical line. And this here shaded, all of this is below the x-axis. And again, I'm going to say 10. And I know this time it looks bigger than 10 because, compared to whatever I wrote last time. A to B of f of x dx, because it's below the x-axis, all of it, we're going to say that is negative 10. Area can't be negative. This is just the integral symbol. Do you know what I mean? Like what that means. So that's like saying, I don't know. Well, I do know. That's like saying, imagine okay, let's just do something simple. So a train travels negative 50 miles per hour. So this is the x-axis and negative 50 miles per hour. After 3 hours, how far has the train traveled? Well, it's traveled negative 150, but negative 150 has direction. That's a vector. So it's traveled 150 to the left. Does that make sense? Okay. All right. Again, guys, this is just the same thing from yesterday. As a matter of fact, I was like, cut, paste. And that's what this is. Whenever you get a chance, read it. We've already kind of talked about all of them. Integral from A to B, integral sign, upper limit, lower limit. X is the variable of integration. The function is the integrand. They're all letters. And then, of course, these letters are dummy variables. It doesn't matter what you call it. So, yeah, all that stuff, pretty simple, straightforward. All right, go to the next page. These are the properties that we got to know. And don't worry, we're going to talk about all of them. That's why I put, let's chat about the rules and see if they make sense. So let's talk about the rules, guys. Order of integration. I don't like that they put a B down there and then an A and then A, B. I wish I would have done A, B, and then B, A, but whatever. I'm not going to do it the way they did it. So let's talk. Let's chat. A, B. And again, this is still 10. Excuse me. This is still 10. So right now I have integral from A to B, and I got to call this something f of x dx is 10. It makes sense. So I'm doing number one, order of integration. It makes sense that if I switch this B to A of f of x dx, that it's going to be negative 10. Why does it make sense? Because I am counting backwards. On this one, on the top one, you start at A and you work your way towards B. So it's like saying B minus A to find that distance, right? On this one, you start at B and you work your way towards A. So look, starting at B, working our way towards A. So you're going backwards. So because you're going backwards, negative. Does that make sense? Mazuka, does that make sense to you?
Yes.
Okay. All right. And then rule number two. Yeah, rule number two makes a, man, this is a beautiful one. A to A of f of x dx equals 0. Why? Why does that equal 0? Because what?
I was gonna say because you started and at the same spot.
Because you started and ended at the same spot. You said, Godina said it doesn't move. Perfect. You start and end at the same spot. You do not move. If you do not move, is there any way that you can calculate area? No. So it makes perfect sense to me. A to A of f of x dx is 0. So that takes care of rule number two. Constant multiple rule. Okay, let's do the constant multiple rule. Let's do it with something simple that we can all agree on. I'm going to say I have a function, a linear line, and I'm going to call it that it's y equals 3. And I'm going from 0 to 2 of this function. So right now, notice that I just have a rectangle. What's 3 times 2? Okay. Now look what happens if I go integral, and let me choose a different color. Integral 0 to 2 of 3 f of x. Well, that 3f of x just means I was at 3. What's 3 times 3? 9. So now I'm up here at 9. So now it's the area of this green rectangle. See? So what is 9 times 2? So what is this? What does rule number 3 say? That I can just take the... Oh, sorry, guys. Mine just turned off on me. Did it turn off on everyone? It did. What the heck? Why did it stop? It crashed. Oh, my God. This is the first. It has never crashed before. Hold on. Can you believe that Dropboard PDF crashed? Because I can't. Draw. Why would Dropboard PDF crash? Man, it has never done that to me. It at least saved it. Okay, let me fix my third monitor here, guys, or second monitor, so I can see everyone. Okay. All right, it makes sense, guys. Finally, we're back. It makes sense that I can pull the 3 to the front, integral from 0 to 2 of f of x dx. And yeah, this part was just 3. Oh, wait, no, it was that part was just 6. Part was just 6, and 6 times 3 is 18. There it is. It works. See? Oh, because I put 3 times f of x, and f of x was just a linear line 3. So 3 times 3, so 3 times f of x is 3 times 3, which is just 9. So that's like graphing the line y equals 9. You know what I mean? Okay. Sum and difference rule, that just means you can break them apart just like derivatives and limits. I don't think it's a huge deal. And then the additivity rule, that one is kind of a big deal. Do I have enough space? Yeah, I'll just make some space. I'm going to erase this part here, guys. I still can't believe that it crashed. Maybe it's time for a new laptop. Okay. If I have, here's a function, f of x dx. Here's the letter A. Here's the letter B. Here's the letter C. Oh, the function's called f of x. Sorry. No. I say what that additivity function says is that I can go integral, here's the green one, from A to B of f of x dx, and then the neutral color plus, and then let me do blue because I shaded blue there, B to C of f of x dx, that all that just equals integral from A to C of that same function. That's all it means. So all you got to notice is starts at A, the green one starts at A, stops at B. When the green one stops, the blue one better begin. So notice that those have to match. Starts at B, ends at C for the blue one, so A to C. So that's going to be all the area. And it makes sense. Pretty straightforward, I think. Does that make sense to you guys? Okay. I think we're ready, guys. I think we're ready. So here we go. Suppose that the area from -3 to 0 of g of t dt equals square root of 2. Find each integral. They flipped the limits and they wrote g of t. What's going to be this one? Negative square root of 2. Go to B. They just changed the letter. It doesn't matter what you call the x-axis. We still found the area of g, whatever you call it, from -3 to 0. So that's just going to be square root of 2. Remember, it's a dummy variable, guys. I can take the negative out. -3 to 0 of g of x dx. So negative, and then -3 to 0 is just square root of 2. So C is just going to be negative square root of 2. Letter D, I have a constant in the bottom. If you want to think, let's rewrite it so you can see the constant better. -3 to 0, 1 over square root of 2, g of r dr. Maybe you see it better that way. So I can pull this constant to the outside, 1 over square root of 2 integral g of r dr from -3 to 0. And g of r dr from -3 to 0 was square root of 2. So 1 over square root of 2 times square root of 2. That's going to give me 1. Let's go to the next one. Oh, that it? All right. Do you guys want to try this? See if you guys can figure it out. All right. Take a 30-second head start, guys. Not all of them are going to be possible. Wait, on this one? Oh, wait. On this one, I think all of them are possible. All right, I'm going to go ahead and start, guys. Let's see if you guys got them right. I have 3 integrals, f, and g. Notice the f is going 1 and 2, 1 and 5, and -4, 6, and 8. All right. Letter A, from 2 to 2 of g of x dx. I haven't moved. That's a 0. Letter B, 5 to 1 of g of x dx. Well, 1 of 5 of g of x dx was 8, so the integral from 5 to 1 of g of x dx is going to be -8. Letter C, This is the same thing as saying 3 times the integral from 1 to 2 of f of x dx. So 3 times -4, so -12. Okay, on this one, relax, go slow. Not to scale, look, this wants the area from 2 to 5. So I'm not drawing, disregard that number, the -4, because I know the -4 means below the x-axis. Think about a graph. Here's 1, here's 5. And I'm just going to call that f. It's not f because I know from 1 to 2 it needs to be -4. So don't think about that right now, guys. So from 1 to 5, this is my total area. And yeah, I know it says 6. Don't worry, it's a concept that matters. If I take that in red and I subtract the area from 1 to 2, so notice I'm subtracting the area in blue here. If I subtract the area in blue from the area in red, won't that give me the integral from 2 to 5? Do you guys see what's going on there? So I'm going to rewrite what I'm trying to say, guys. The total area from 1 to 5 of f of x dx, make sure to put the dx in there. And if I subtract the area under the curve from 1 to 2 of f of x dx, that will give me the area from 2 to 5. And hopefully that visual up here will help. The area in red from 1 to 5, and I'm subtracting the area in blue. And what do you have left over? I guess I'll choose another color. You have left over this in green, which is from 2 to 5. Does that make sense to everyone? Perfect. So let's see. The area from 1 to 5 for f of x was 6. So I'll put 6 minus the area from 1 to 2 of f of x dx was -4. So -4. 6 minus a -4, that is a 10. Obviously, I did not draw that graph correctly. I just did that as a visual. Okay. Let's see the next one. This one, we can just separate it, guys. That's your sum or constant difference. You can just go 1 to 5 of f of x. Did I say constant? The sum or difference of your integrals there. Minus integral from 1 to 5 of g of x dx. That's all you're doing. So from 1 to 5 of f of x is 6. So I'm going to write that. Minus 1 to 5 of g of x is 8. So 6 minus 8, -2. Let's go to the next one. Again, we're just going to go for integral 1 to 5. And of course, you don't have to do this if you know what you're doing, guys. I'm just showing it the baby steps. I think realistically, you would just go right into it and just type in your numbers. 4 times 1 to 5 was minus, and then 1 to 5 was what again for g of x? Okay, 4 times 6, that's 24, minus 8. So we're going to get 16. Cool, guys? Cool. All right. Do you guys want to try these ones out on your own? See if you guys can get them right. Try them out, guys. Give you a 30-second head start. There are some that are not possible. So I think I count 3. All right, I'm going to go ahead and get started. Let's see. They give me f of x and h of x. They don't tell me anything about f of x, like how it looks, if it's even or odd. I think if they would have told me that, I could have probably answered one more. All right. 1 to 4, 4 to 1, sorry. From 4 to 1, integral from 4 to 1 of f of x dx, that is a 2. Letter B. From -1 to 4 of f of x dx. Well, where this one stops, so let's see if I can draw this. -1 to 1 of f of x dx. Where this one right there stops, the other one better begin, and it does. 1 to 4 of f of x dx. So I can add these two numbers up. 5 plus a -2. So that's going to be 3. negative 1 to 1 of f of x and h of x. Well, 2 times f of x plus 3 times h of x. All right, so let's see what this is. I'm just going to go ahead and go right into it, guys. I see f of x right here. So 2 times 5 plus, I see h of x right here, and it has the same limits. 3 times 7, and there it is. 2 times 5 is 10. 3 times 7, 7, 14, 21. So I get 31. 0 to 1 of f of x. No. Sorry. I was looking. We have from negative 1 to 1. No, wait. Let me draw a picture, guys. Negative 1. Negative 1 to 1. And that is this integral. And then we have 1 to 4. And that is this other one. Nope, we don't have enough. If they would have told us odd or even or something, then we would probably be able to figure it out, but not enough info. If they would have told us that f of x is an odd function, then we could have just, no, we couldn't. We couldn't have, because if it was odd, that would have been 0. But if they would have told us it was even, we could have divided that by 2. If it's even, it's going to be symmetrical on the y-axis. And if it's odd, it would have zeroed out because you would have some area below the x-axis, some area above the x-axis. So from negative 1 to 1, if it would have been odd, it would have been 0. Does that make sense? Negative 2 to 2 of h of x, they don't give us enough information. We do not know what is happening outside the boundaries of negative 1 and 1. So not enough info again for that one, guys. Letter F, negative 1 to 4 of f of x plus h of x. Let's see. We have enough info for F. F has enough info, negative 1 to 4. But does H have enough info? Nope. It's the H that is messing it up on letter F. All right, guys, last one. Last page. See, these aren't so bad. So let's see what it says. This is what your delta mass is going to be today, guys. So it's going to be a simple one. The region A, B, and C in the figure below are bounded by the graph of the function f and the x-axis. The area of region A is 18. Okay, 18. The area of region B is 14. 14. And the area of region C is 8. 8. What is the value from negative 5 to 8 of f of x dx? All right, negative 5 to 8 of f of x dx. I notice negative 5 is right there, and I notice 8 is right there. So I'm going, let's see, negative 5 to 8, left to right. Perfect. That's how you should be reading a graph. If it's below the x-axis, it's negative. If it's above the x-axis, it's positive. So negative 18 plus a negative 14, or if you want to write minus, that's fine, plus 8. Negative 18, 28, 1 to 2, negative 32, plus 8, 32, 22, 24. Negative 24. And that's it, guys. All right, let me come back. You guys